Welcome back, everyone. What we're getting into here in our next chapter. So we'll beginning the next chapter with, and all we're going to unfortunately have time for are 3 sections, much to your dismay, I'm sure, for the remaining 2 weeks of the semester. But we're getting into properties and how do we solve for inverse functions and how do we find them, the key information about them. So the real important information to make sure we keep fresh in our minds would be stuff back to chapter 2, in particular section 2.4, if you need a refresher on terminology associated with functions such as domain and range, vertical line test, how do I know if something is a function. Very important stuff to make sure you are totally familiar with throughout this process, as it will be used here. So a big idea in math, when we learn a process, we learn how to undo a process, right? So if I learn how to double distribute or FOIL, I then learn how to do the opposite, which is to factor. I can square something, I can take its square root, and those are opposites of one another. So the inverse of a function, I would take a pause, jot down the key information on both boards here to begin with. The definition of it is that, very similar to a function, it is a rule. It could be an equation, could be a mapping table, graph, but it is a rule that assigns each element of the range back to elements of the domain. So the key thing there, the definition, if you go back to function, that takes elements of the domain, the x values, and assigns them to elements in the range. But you can notice that these are flipped, so the opposite. The notation for an inverse function is this. It is an f, kind of like that, that function label with a -1 superscript there. It is not an exponent. It is read as f inverse of x, just like f of x is read. And then another key thing, this is not a negative exponent. So as I said, not a negative exponent, it is a label meaning inverse. And the key idea that I want you to keep in mind through this whole section, inverse functions exchange the inputs with their outputs. Okay, so x to y, input of x, output of y, now flips to input of y, output of x. Moving on to the next board here, just to kind of show you a visual of how this works. So let's say I have a function, and I've mapped out the original points here. So the domain of the x's, range of the y's, and right now I have a function f that just gives me 2 points right now, 2 to 7 and 3 to 8. So x value 2 paired with y value of 7. If this were the function, that would mean that f of 2 is equal to 7. Likewise, f of 3 is equal to 8. Now, if I do the opposite here, I'm going to color code here with the inverse here a little bit. We'll use blue. The inverse of this function simply flips the order of the inputs and the outputs. So if I start at 7 and go to 2, let's call this f inverse. Start at 8, mapped to 3. This takes the original outputs, matches them to their original inputs. So if I were to color code my points that are in the inverse of this function, I would say that f inverse of 7 is equal to 2. So input of the original y value goes to the original x value of 2. F inverse of 8 maps to the original input of 3. So again, if you compare top and bottom here, you can hopefully see it's an exact reversal of what we just did. So the inverse maps the original output with its original input. And you can kind of see, it comes back full circle with each point there. So again, key idea, flipping x's and y's, exchanging inputs with their outputs. So the 2 key ideas that we're going to see here in this section. First of all, how do I determine if a function has an inverse? Not every function will. And then from there, how do I determine what the inverse function of 1 is? Think of one I just said earlier today. The inverse of squaring is a square root, or the inverse of adding 3 is to subtract 3. So we're going to see a lot of opposite operations. So first, determining whether a function has an inverse. All right. Now this is going to be a visual test. Think back to functions. We know that the vertical line test tells us flat out if something is or is not a function. The keynote here to determine the existence of an inverse function we use the horizontal line test. Okay. So to determine the existence of an inverse, we use the horizontal line test. Now, a keynote here that I would jot down with this, a horizontal line test, if it passes, does not tell you what the inverse is. It just confirms that you do have one or not. So, just two brief examples here. Does the graph of each function have an inverse? Okay. And again, this is a very simple test. This is where pictures of our common graphs are going to be very, very important because you can get a very good idea in your mind before you start going through work whether or not something is going to have an inverse to begin with. All right, so I'm going to jot this one down quickly. So does the graph of this function have an inverse? Now I didn't tell you what the equation is, but hopefully you would know this would be something that would be in slope-intercept form, y equals mx plus b. It is a diagonal line on a graph. So here is how we show the horizontal line test. The visual of it is that I simply, instead of taking vertical lines to see if it hits more than one point, I take horizontal lines to see if it hits more than one point. So what you can see is that anywhere I draw a horizontal line, I will only ever hit one point. So the conclusion in here is that we'll say by the horizontal line test, an inverse exists. Okay. So by the horizontal line test, an inverse does exist because it passes. I never hit more than one point with each horizontal line. Okay? To show you one that would not work or would not have an inverse. Let's say I have this function on a graph. So it is a function because it passes the vertical line test. However, this is an example of a function that would not have an inverse, because if I take any number of horizontal lines, what you can see here is I'm actually going to be hitting this graph in two different places with the same, actually more than that, in three different places with the same horizontal line. So this is the opposite conclusion. If I hit more than one point with any horizontal line, that tells me an inverse does not exist. All right, so what this test is going to do for you, it will save you work, because if I say find the inverse of a function if it exists, if you just think through the graph and you find the conclusion that an inverse doesn't exist, you're done at that point. So again, the key here, the horizontal line test, as long as we keep in mind our common graphs of functions, is a very, very easy way to determine the existence of an inverse. Okay. So the culmination of this section here then, if an inverse exists, like number one, it would have an inverse, how do I find out what that is based on the equations of these things? Okay. So how do we write inverse functions? And what I'm going to do on this board here is down the left side, I'm going to do an example of one following a step-by-step method here. therefore, how do we write the equation of an inverse? So we'll say, write the inverse function if it exists. Okay, so write the inverse function if it exists. The first one we're going to work with here is f of x is equal to 6x minus 11. Okay, so before I even write the steps down, what I want you to think through, and then I'll get into it here in just a minute, does this have an inverse? If I were to graph this, would I know that it passes the horizontal line test or fails it? The answer to that is this passes the horizontal line test. This would be the equation of a line. Remember, f of x and y are the same thing. I could think of this as y equals 6x minus 11, equation of a diagonal line. So for this one, an inverse definitely exists. So because this is linear, and then which would mean it passes horizontal line test, an inverse exists. Okay. Which means we go through the process. We'll go through this step-by-step method. So first thing, I guess determine if it has an inverse. Okay, and that'll be horizontal line test. Think of the graph. Okay, so determine if it has an inverse. If it does not, we're done. There's no need to go any farther. Step 2, here's what we do. Replace f of x with y. Okay. You'll see where that makes it a little more easy to work with here. So what I'm going to do, I'm going to replace f of x with y, and I'm going to recopy my original. Y is equal to 6x minus 11. Step number 3. Going back to the definition of what an inverse does. Remember the thing I started on the very first board of the notes here. Exchange x and y. That is what an inverse does. So I'm going to exchange, we'll say swip, swip, switch, or exchange x and y. So let's do that. My new equation is x equals 6y minus 11. What I now do to find the inverse function, I just have to get the new y by itself. So we'll say solve for the new y. Okay? So this is going to involve 2 steps. Think the opposite of minus 11. Again, inverse, we're thinking opposites, is simply to add 11 to both sides. So I get x plus 11 equals 6y. Finally, divide both sides by 6. Both parts by 6, of course. And what I'm going to do here, I'm just going to rewrite, exchange the left and right side. This now has y by itself equal to x over 6 plus 11 over 6. Final step, just notation purposes, replace y with f inverse of x. So you can see here our new equation is also a line. It's just an x to the power of 1. This would be our inverse function. Okay, so again, recap those steps. Again, test to see if it has an inverse first. If it does, rewrite y, replace it with f of x, exchange x and y, solve for the new y. So this is the inverse function of what our original was. Next, we'll do a second one here. Okay, number 2, f of x is equal to x squared minus 9. Okay, so for this one, what I want to think about is again, what would this look like visually? That's going to be something very important that I always want you to keep in mind for this. If I were to graph this, hopefully you can come up with a good example or a fairly accurate sketch of this, even just in your minds. This is a parabola opening upward with a vertex at 0, -9. Okay, with that sketch, hopefully you now see that fails the horizontal line test. Therefore, no inverse function exists. I'm done. So if I were to say write the inverse of that function, there is not an inverse function for that. Okay, final one that we'll do here in this section here. To wrap up, one last example. Do f of x is equal to 2x cubed plus 4. All right, so once again, this is a cubic function. Let's get a look, or let's think through what this would look like on a graph. Without getting too specific, this function is roughly going to do that. Okay, so the cubic function, remember, kind of flattens out at a point, not flattens exactly, but kind of has that effect going off into the third and to the first quadrant. So if I run the horizontal line test, you can hopefully see that this will pass. This passes the horizontal line test, so I know that an inverse function exists. So let's go through the step-by-step process we did for number 1. We exchange f of x with y. Now I flip x and y. So I get x is equal to 2y cubed plus 4. And as we did in the last question, we are simply going to solve for the new y with any equation strategies that we have. First thing I would want to do is subtract 4 from both sides. Next, we would divide everything in the equation by 2. So I have x minus 4 over 2 equals y cubed. And now, again, thinking inverses, I'm going to take the cubed root of both sides of this equation. I'll jump up here a little bit. So again, square root undoes a square. Therefore, a cubed root undoes a cubed. I'm just going to reverse sides of the equation once again. So I now have y by itself equal to, I'm going to write this as x over 2 cubed root of minus 4 divided by 2 is simply 2. That's it. I know it's kind of messy, but that's our inverse function. So it's going to be f inverse of x is equal to the cubed root of x over 2 minus 2. So again, there's your final example there. Again, to recap the process, first determine if an inverse exists. Exchange the x and y's of the original equation because that is what an inverse does. It flips the input and the output. And finally, solve for the new y in order to get your inverse function in order. So again, as usual, suggested homework posted online along with this video. And that'll be all.